Hello students, today I will discuss about greatest coefficient and the greatest term. Here I have already written the theory of the greatest coefficient and the greatest term in order to save our time, so that we can concentrate more on solving the questions. It doesn't mean that I won't be explaining about these theories, okay? Of course I will. So let me explain what is greatest coefficient. See, the coefficient of middle term, remember, okay, the coefficient of middle term will be the greatest coefficient of an expansion. Okay, so for our expansion x plus y power n, what will be the greatest coefficient? See, greatest coefficient is equal to nc n divided by 2. okay, nc n divided by 2 when n is even, and when n is odd, the greatest coefficient will be nc n minus 1 divided by 2, nc n plus 1 divided by 2. Here, and when n is even, the total number of terms you will have what? Odd, right? Odd number of terms will be there, and in case of odd number of terms, there is only one middle term, so there will be only one greatest coefficient. Got it? And when n is odd, suppose 9, so the total number of terms will be 10. The number of terms will be even, isn't it? We have seen this in middle term. So in that case, we will have two middle terms, that is nc n minus 1 divided by 2 and nc n plus 1 divided by 2. So let me tell you something about these 2 points. See, I have already written a note. nc n minus 1 divided by 2 and nc n plus 1 divided by 2 will be equal. Okay, both will be equal. Greatest coefficient is independent of x and y. Whenever you write the greatest it doesn't mean that the middle term will be independent of x and y. Here, greatest coefficient is independent of x and y means when you write the greatest term, you don't write x and y with it. Okay, so the greatest coefficient is independent. Just write the coefficient, no need to write x and y. Okay, for example, let me give you an example. See, a very simple example. X plus y whole square. You already know this identity, isn't it? X plus y whole square. X square plus 2 times of xy plus y square. Here, what is our middle term? This, isn't it? So the greatest coefficient is 2, independent of x and y. So when you write the greatest coefficient, just write 2. No need to write x and y along with it. Okay, here n is even, isn't it? 2 is even. And when you write x plus y to the power odd number 3, how do you write? In binomial form, 3c0 x power 3 plus 3c1 x power 2 y power 1 plus 3c2 x power 1 y power 2 plus 3c3 y power 3. So in this case, see, when power is odd, you have even number of terms, so there will be two middle terms, isn't it? Separate, bring this to the left and this to the right, so there will be two middle terms. And what is the coefficient of middle terms? 3c1 and 3c2. Okay, and in the note I have written that both the coefficient will be equal, isn't it? So is this equal? Yes, of course this is equal. 3c1 is 3 and 3c2 is how much? 3c2 is 3c3 minus 2. NCR equals to NC n minus R, isn't it? So this is 3c1, which is equal to 3. So here you are getting both the coefficient equal. Okay, you can directly use the formula NCn divided by 2 in this case. In this case you can directly use the formula. The first example, when n is even, the middle term will be the greatest coefficient, isn't it? What was the greatest coefficient formula? NCn divided by 2. 2, n is 2, c, n is 2 divided by 2. How much you got? 2c1, which is nothing but 2c1 is 2c. From the formula also you are getting the same thing, 2, isn't it? And here also you can apply, in the second example you can apply the formula. When you apply the formula NC n minus 1 divided by 2, so your formula will be 3c 3 minus 1 divided by 2. 3c 2 divided by 2 is 1 and 3c1 is 3. Using the formula also we are getting the same answer, okay? Or we already know the expansion or the identities. Anyway, I hope you understand this. So let me move on to the greatest term, okay? We have completed greatest coefficient and I hope it is very clear. So let me move on to the next topic. See, the next topic is greatest term, okay? So there are two methods to find the greatest term in an expansion x plus y power n, okay? So the first method, what does the first method says? The first method says we are just considering that the general term tr plus 1 be the greatest term of an expansion. Suppose tr plus 1 is the greatest term in an expansion, so the tr plus 1th term will be greater than tr, isn't it? And again tr plus 1 will be greater than tr plus 2. See here, you have got tr and here you have got tr plus 1, right? Here you have got tr plus 1 and here you have got tr plus 2. Okay, so suppose tr plus 1 is the greatest term, then this will be definitely greater than tr and this will be greater than tr plus 2. Okay, so let me rub it. So I hope you understand both these cases. tr plus 1 is greater than tr and tr plus 1 is greater than tr plus 2. So bring this term to the denominator here and bring tr plus 2 to the denominator here. Now you have got two inequality. When you solve this both inequality, you will get a value of r, isn't it? So tr plus 1 term will be the greatest term. You put the value of r, whatever the value of r you get by solving these two inequality, you will put here. In place of r you will put whatever value you got, okay? So this will be your greatest term. This is our first method. Let us move on to the second method, okay? The second method is very easy if you remember this simple 3 steps, okay? And I will solve a equation using this method. So see, first step is you have to calculate m, okay? You have to calculate a variable m. How do you calculate m? In an expansion of x plus y, x plus y power n, okay? How do you calculate m? M is equal to x, okay? The first thing is you will calculate, you write mod x, okay, into, let me rub this is not needed, okay. First you will calculate m. I will give you some example, it will be very clear, okay. Forget about that which I have written just now. Let me rub it. M is modulus of, remember you have to put here mod x, okay, mod x into n plus 1 divided by mod x plus 1 whole mod. M should not be negative, okay. I am just considering the positive magnitude, so I have written here mod. Now after solving this, if you get m as an integer, if m comes out to be integer, then there will be two greatest term. The first one will be tm and the other one is tm plus 1. There are two greatest term and both will be equal, okay. Remember, the third step says if m is fraction, if m comes out to be fraction, okay, then t greatest integer of m plus 1, this box is greatest integer, okay, greatest integer function, okay. So tm plus 1 will be the greatest term. This box is greatest integer function, this box. So you just need to remember these 3 steps in order to solve the problem, okay. Here also there is some note, you have to remember it. See, numerically, the first note is numerically the greatest term in the expansion of 1 minus x, okay. Here x is positive and n belongs to any natural number, is same as the greatest term in the expansion of 1 plus. See, here it is 1 minus x and here it is 1 plus x. So when we find the greatest term, we are just finding the numerical value, okay. So don't consider the sign. The numerical value will be the greatest term, okay. The second point says to find the greatest term in an expansion of this one. Whenever you need to find the greatest term in this type of expansion, the first step is write it as 1 plus something. So in order to write 1 plus something in the bracket, you will have to take x common, okay. So when x come out, it comes along with the power n. So in the bracket you are left with 1 plus y by x whole power n. Then find the greatest term in the this 1 plus y by x power n, okay. Now it will be clear to you when we solve, okay. See, let me first tell you what is greatest integer. Many of you may not be knowing. For example, I am just drawing a vertical line, okay. See, draw a vertical line. There is y-axis, we all know, isn't it? 0, here you have got 1, here you have got 2, here you have got 3, here minus 1, minus 2, minus 3, isn't it? Minus 3. So whenever you are told to find the greatest integer, for example, just take a number here in between 2 to 3, any number, suppose 2.7. What will be the greatest integer? The answer will be 2. Just take the integer below it. Okay, so below 2.5, what is the integer? 2, right? So your answer will be 2. Suppose you took from 0 to 1 any number, here you take 0.7, so your greatest integer will be the integer just below it, that is 0. Come to the negative part. Suppose you are taking here minus 2.5, so the integer just below it is minus 3. So remember, see here, in case of positive the greatest integer is 2, but in case of negative the greatest integer is minus 3. So don't get confused, okay? Just draw the vertical line and you can check it. When you take any number between minus 1 to 2, suppose minus 1.5, what will be your greatest integer? Minus 2, isn't it? So let me give you an example of finding the greatest, numerically greatest term. Okay, let us start how to find the greatest term. Write it down, find the numerically greatest term in 1 plus x power 13 when x is equal to 2. This value will be given to you, okay, when x equals to 2. So how do we find the greatest term? First we will write m. We will calculate m. M is equal to modulus of what? X, isn't it? X here is 2 and n plus 1. Look at the formula and just I am substituting the value. N is 13, so 13 plus 1 divided by what? Mod of x plus 1. Mod of 2 will be 2 plus 1. Okay, so your answer will be 2 into 14 divided by 3. What is the answer? 28 divided by 3. It is 9 point something, isn't it? Whatever is the point, it doesn't matter, okay, when we are calculating the greatest function. 109.3, it will come something like that. So what is the value of m here? 9.3. Is it a integer or a fraction? It is a fraction, right? So when you get m as a fraction, what will be the greatest term? First calculate greatest integer of m, isn't it? The greatest integer of m will be 9.3. What is the greatest integer of 9.3? The integer just below it is 9, isn't it? Okay, so your greatest term will be, therefore greatest term is equal to t greatest integer of m plus 1, which is equal to say t of 9 plus 1, which is equal to t of 10, isn't it? So your 10th term will be the greatest term. Okay, the greatest term is t10. So we calculate t10 is equal to 13. See, I have told you before also, whenever you write the term, the suffix of c here will be 1 less than this, isn't it? The 10th term will have 13c what? 9. Okay, 13c 9, and you got x to the power 9. So 13c9, what was x? 2, right? 2 power 9. This will be your greatest term. Okay, so I hope student you understood how to find what the greatest term using those 3 simple steps. Okay, you just need to remember the first steps, and if you get